Hey yo, what's up YouTube? It's your boy JOSHABRAHAM. Where you know what it is. We're back with the analysis. Sequence analysis. Sequence anal? No, sequence analysis. Stop doing that, okay? Uh, uh where is the assignment sheet? There we go. It's too fucking bright. Uh, Fucking bright, bro. It's fucking bright, bro. It's fucking bright, dog. So I have to multitask this because it's not just I have to do the assignment. I have to send some emails. Wait. So for exercise 17, this exercise is just we have to find we already have the transition probabilities. We have to find the what was it? There was one more, not just transition. Yeah, mission matrix, mission probabilities. So those and form the word to buy table. That's for example 16 exercise 16, exercise 17. You're asked to compute the probability of observing a sequence of hidden states U or V given the HMM parameters, initial probabilities, and transition matrix. This is not about the emission, only the hidden states themselves. Start with the initial probability. Dude, oh. Again, I get distracted. I got distracted. Here's how to approach it. Start with the initial probability for the first state in the sequence. Use P init. Okay. Wait. You're given the sequence of hidden states. These are 5 hidden state correspondent to the unknown copy number. Calculate the okay, can we start with explaining this question? Can we can you start with explaining this question because I am really new to this whole thing. Can't remember. Below is a clean. Okay, what is the question about? You're working with a hidden Markov model that describes how copy numbers of DNA segments change along the genome. How copy numbers of DNA segments change along the genome. How, again, I kind of forgot what copy numbers were. A copy number copy number variations are one of the main sources of genetic variations in a mammalian genome. So, copy number variation, copy number. Okay. Each DNA segment has hidden state. Yeah, these states are hidden because in reality you don't see them directly. Instead, the model assumes these states change step by step along the DNA. What the question gives you, you are given 2 possible hidden state sequences. Each number corresponds to the copy number state of 5 consecutive DNA What is the question? Calculate the probability to observe these hidden state vectors. Calculate the probability to observe these hidden state vectors. Okay, so my first question is so here these 2 U and V, I'm guessing those are 2 experiments to DNA, like 2 different samples, and the numbers in them are the same as the hidden state, with 1 for deletion, 2 for normal amplification. Yes, your interpretation is almost. It's not correct. It's almost. What UNV actually are? UNV are not 2 different experiments. UNV are 2 hypothetical explanations for the same kind of experiment. They are 2 candidate hidden state path through the HMM. Okay, I need more explanation. Okay, I still didn't kinda get it. I only know got to know a simple model with the rain and with or based on weather and mood. So I'm not exactly sure how that HMM model is applied here. Like I kinda know instead of the weather, here it's the states 1, 2, 3, but I'm still not sure what's the mood part replacing here. And could you explain on the UNV? They are hypothetical. And could you tell me what those numbers in the brackets mean on a if this was a real experiment, right? How did we get 5 states? Take me through if the UN how would have they been done? Likelihood of observed data. Calculate the likelihood of given observation in the following weeks. Enumerate all 3 raised to 5 equals to 43 possible hidden state sequences and use the procedure for X. Recall the classic weather mood HMM, weather mood example, sunny, rainy, happy, sad. You observe moods, happy, sad, do not observe weather directly, weather changes slowly, transition probabilities, weather causes moods, emission probabilities. Oh, okay. Emission. Now translate that exactly to this DNA problem. Sunny, rainy, 1, 2, 3. Mood, probe intensity, days, DNA segments. Transition probabilities, where is the probe intensity? Correspond to a probe with the intensity of new one. What are the hidden states here? Hidden states equals copy number status of DNA. 1, deletion. 2, normal. 3, amplification. You cannot directly see copy numbers. You can only see light intensity from probes. What are the hidden states? You cannot directly see copy numbers. You can only see light intensity from the probes. Okay, okay. Canada. I have to send the reply to the professor. Just a minute. I need the GPT out. Oh, wait. What's wrong with you, GPT? Email drafting. Put it out. No, not that. How do you bring it out? Share link? No. How do you? Okay, there we go. Dude, ChatGPT is so slow. I can't wait to run a fucking native local LLM. Okay, let me just complete this. Oh, okay, it's big now. What the? Oh shit. Okay, now it's working. Okay. uh, as part of myself. Um, really. A lot of Japanese music. Kana. Oh, come on. State you accept now, no compensation. Over explain grades. Now I don't have to over explain grades. I fully understand and accept the conditions you mentioned, including the absence of financial compensation and need for sufficient time commitment. My primary motivation is to. I have an important exam on January 9th. From that date onwards, I will have significantly more flexibility and reliably dedicate on time on a regular basis. I will be enrolled on JQ. So I'm so not like enrolled. Well, I would not describe myself as an academic top student. I'm highly motivated, disciplined, and learn particularly with my hands-on work and reliable application. I'm more confident that my about payment important. What do you think it is normal, but it's not the moment to say it. Typical path to. If you perform well, they will bring it up. Asking now weakens your position. What hours to So AI generated. This looks like a good response. I understand. I have important exam, and from that date onwards, I have flexibility, and can dedicate a regular time to lab work. I plan to be at JQ Linz until the end of this. I will spend a year at the University as an instructor as part of my curriculum, then return to KU. While I'm not among the top performing students yet, I learn more effectively, most efficiently by observing and practicing. I hope this opportunity will allow me to contribute meaningfully while improving my skills. Please let me know if this aligns with your expectations. I can also write a proposed video for more than this. I would uh, rather than proposing fixed hours in advance, I would appreciate guidance on what level of weekly coaching. Okay. This. Uh, should I? Dude, I fucking hate this. I guess that's the reply. Okay, I'm gonna send it. Yep, that's how it. That's how it is. That's gone. Huh. Mm, 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 mm. Oh shit! I should be doing this, right? Then what are UNV? UNV are not experimental results. They are two possible hidden explanation for same five segment. Oh, okay. Okay, okay. So think of them as two guesses for what the hidden copy number path could be. Both are biologically possible. Oh, so HMM tells you which is more likely. Okay, okay. So I'm guessing. So so this this would help us to know what's more probable and help us know what's more probable and come on. Yeah, that's exactly the point. Okay. What would be compare you and we? Because copy numbers does not jump randomly. Staying in the same number state is likely. Switching states is penalized. So V has no transitions. U has two transitions. What do you mean? V okay. U has two transitions from two to three, three to two. The question is, given the transition rules of the genome, which hidden path is more probable? What is replacing mood here? Here, nothing. Mood has not used yet. This question uses only the hidden state chain. If you and we were a real experiment, how would this happen? You measure probe intensities. You do not know the true copy numbers. HMM considers all possible hidden paths. Example, yeah. The algorithm asks which hidden path is most likely. Exercise 17 says compare these two specific candidates. The HMM is used to decide which history is more biologically plausible given how copy numbers tend to change along the genome. So from this, you get, if you want, okay. So from these probe intensities, how do we know? Or penning, or heck, even if uh, this is the exact point where most people get stuck, so I'll be very direct. Short answer first. You do not know the probe intensities, whether is happening. Exercise 17 is not asking you to infer them from X. Okay, if it is asking something simpler or more fundamental, what, okay. If these hidden state sequences occurred, how likely? Okay, I get it. So you're not, I get the question 17. I need to know how does. Okay, okay, I did understand the point. I to know how do we arrive. Okay, okay, I kinda. How do we start with the exercise 17? So write down what you're given, transition matrix, initial probabilities. We are not given the observation for this exercise. You do not need them. Write the general formula for any hidden state sequences. Ah, my god. Oh my god. If you write this line in the exam, you're already doing well. Oh shit. Uh-huh. Y is sum of t equals 2 to 5. I mean, I get the 5, but what's the 2? Oh. Dude, I fucking hate this. Okay, okay, I'm getting distracted. So this is the equation, and applied to each sequence, start in state 2. Stay in state 2 4 times. Uh, This is exactly the right place to slow down. I'll strike down the formula, what the formula is doing. It calculates how likely a specific sequence of hidden state is based only on where you start and how likely each step. Don't panic. Oh, bro, shut the fuck up. Now let's decode every symbol. What is This is just a list of hidden states. Example, yeah. No mystery, just labels. What is PS? This means the probability that the system went through exactly this sequence of states. Not observations, not intensities, only the states. So it's 5. This is the probability of starting in the from the question, what? So it's 0.95. Okay, okay. Why does the product start at t equals 2? This is the key confusion you had. Good catch. Recent t equals 1. There's no transition yet. We start in the state. Transition only happens when you move from the state at time t equals 1 minus 1 to state at time t. So the first transition is S1 to S2. That's why t equals 2 to 5. It has nothing to do with states being equal or ignored. What does A mean? This is the probability of moving from one state to the next. Then probability of going from state 2 to state 3. Mm-hmm. I can be Then probability of going from state to state 2. Mm-hmm. Just look it up in the transition matrix. Uh-huh. What does the big product mean? Simple means multiply all these together, okay? Oh, no, no. Okay, can you do the onto the you I wanna see if I understood are multiplied it's just 4 points, 8 points, okay. 10 points. Picture separating I'm again wasting time. It's 10. Oh shit. Ow. My ears are fucking. No. Uh, Plug in the sequences. This is already correct mathematical expression. Insert the actual numbers. Transition probabilities from the transition matrix A 2.2 probability to stay normal. Normal probability, normal amplification, probability amplification, amplification, probability. You simply look these up in the matrix. Uh-huh. You know what? I kind of get it. I'm gonna end the stream and I'm gonna head to sleep and we're gonna complete this whole assignment tomorrow. Yeah, yeah. We're gonna do it tomorrow. Peace out, YouTube. Peace out, Twitch.